Aloha, Richard Halverson here. This is ICS321, and today is September 10th. And we're gonna continue with chapter 2, and I think we might talk about the next assignment. Let me share my screen. All right, so here we are. So let's look at the syllabus. So we are in this September 10th, yeah, so we must be in this time period. We're still I was thinking for some reason. Okay, so anyway, we are moving right along, I guess. This is so we're going to go through, I think we're going to finish chapter 2 today. We might. Okay, so that'll leave next week to do the normalization project, I guess. So let's see, I said first, okay, so yeah, so we if you look at the last video, we ended at 2.6, section 2.6. So let's go there. However, I do recall there was a question about what they meant by minimal, and what they meant by minimal was minimal as a primary key. It's usually or if it's a minimal candidate key. If it's a minimal candidate key, then it can be a primary key. So let's go see where that is. It was in this one, and it was the challenge exercise. I think it was this. Yes, I think it was this challenge exercise. So let's try to do this and see if that question comes up again. It's kind of big, yeah. Okay, so let's start with the first one. Start. So we want to, I think this is the right one. Okay, so select country name. So it's going to be one of these. From country, the table is country, where the code is 410. So the code is 410. So the country name for the code of 410 is South Korea. So it would be this one. Okay, check. Yes. Okay, here's the minimal thing. All right. Based on the data in the country table, select the properties satisfied by the column ISO. Okay, the properties. Select the properties. What are the properties of this? Let's see. ISO code is going to be unique. So that would be a good primary key. So it would be satisfy the properties of a primary key. Well, anyway, so yes, it is unique because primary key's got to be unique. It is not null. It's always going to have something, and it is minimal. There's okay. So it's not a composite. So if it were a candidate for a primary key and it's not a composite key, then it's going to be minimal. But let's say it were a composite key, then minimal means that there aren't any columns included in that composite key that are unnecessary. It's only necessary columns. So that means it's minimal. The minimal number of columns to do it. So anyway, that's my answer, and I would say yes. And let's see if I get this right. Ah, yes, very good. Okay, I'm going to do the next one. Okay, what is this now? What is the population density of Liberia? Let's see. Liberia is, so this is a yeah, so this is a foreign key. into here. Okay, anyway, so Liberia is LR, and LR is this number here. Okay. Yes, so yes. Okay. The geography tables code column is a foreign key that refers to the primary key of ISO code 2 in the country table. In the country table, the primary key of Liberia LR is LR, of Liberia is LR. So this is the, okay, well, country, okay, yeah, right, okay, there. And so in the geography table, the foreign key LR is that, okay, all right. Okay, so what's next? Let's do the last one. The degree code column refers to the primary key of the degree column. What statements about the degree code are true? Degree, they must mean you know, college degree. And so what statements about the degree code are true? Contains repeated values. This is degree code, and can it contain repeated values? Yes, it can. It does, in fact. Clark Kent and Bruce Wayne are both urban studies majors, Master of Arts. Okay, so it does have that. Contains null values, yes, because Peter Parker does not have a degree code. Are all non-null values match some primary key value? Yes, they need to. Okay. Do they? Yes, they do, and they in fact do. All non-null values match something. Okay. Is degree code a valid foreign key? Yes, because of, yeah, I would say yes. Uh-oh. Oh, good. All right, well, anyway, so that's what minimal is. So I answered that question. Let's see where we are now. We are in chapter 6.7. We just finished joins last time. So view tables, okay. These are a view is a construct. It's actually a stored select statement. It's a stored select statement, and but it is treated, or can be treated, like a table in the from part of a select, of some other select. So so you create a view like this with a statement create view, and then this is a, yeah, it looks like this. Create a view called manager view, and this is what the view, this is the definition of the view, and it's simply a select statement. So so you can use manager view, so you can think of manager view as actually a table, but it's not really a table. It's a pseudo table, or whatever you want to call it, and it's actually got, you know, two columns, department name and manager name, and it's constructed this way, joining the two tables where the manager ID and employee ID are the same. So it's a way to create this table here from these two tables, but you can just treat this as a table, and you know, you can do select and all that kind of stuff with it. And what's the beauty of it is that it will always be up to date. If anything changes over here, then the next time you look at manager view, the next time you look at this, then it'll be updated, of course, because it's sort of made on the fly. So it's just a view, and you know, in your assignments, you're going to create some views. So for example, let's say you want to, what is this? This is a participation activity. Okay, so we're going to create a view named something, named this. We're going to create a view named this. So that would be there. And select here, we're calling it professor, but it's coming from this table. And over here, it's called faculty name. See, Parker is right here, teaching in the math department. And see, the select statement is you're selecting the faculty name as the professor. So B is the professor, and then something as assignment. And this is assignment. So what is this? Well, let's see. I don't know. I guess it looks like this. So this is department name of department. So this C is this, but we're calling it assignment. See, as assignment, and select from these two tables, you know, joining them up, where something over on the faculty table is equal to something over on the department table. So what is it? Well, it's code is equal to code. So this is going to be code. Faculty.code is equal to department.code. Those are the records that we want, because those records are going to have the matched up, you know, when you take the product of these two tables, you know, you get every combination of how to stick these two together. And we just want the ones where the one on this side is equal to the one on this side. Yeah, so anyway, and this again is where department code, where these two are equal. So this is, so E is going to be, oh no, I'm sorry, wait. Okay, we're done here. Where faculty of code is equal to department code, and department code equals faculty, and what does department code have to equal? Oh, math. So we only want math people. So department code has got to equal math. So we're only interested in math right there. Oh, look, it's got quotes around it. That's a big clue. So this one will be math. So anyway, you can click through those. Querying views. So a table specified in a view queries from clause is called the base table. Okay, so that would be, you know, this. Those are the base tables. Unlike base table data, view table data is not stored. So instead, it's just this SQL statement is executed. In some databases, a view data can be stored. So anyway, the thing that may not have occurred to you yet, that I get out of this is, if this can be a view, then why can't this just be another select statement that you could make as a view, but you don't? You just go directly and you put a select statement. You put a select statement with parentheses around it, and that would be like, that would be a table. It would be just like a view, but and we know views can be treated like tables. So can we do that? Can we nest can we nest select statements that produce something that looks like a table right here? Well, the answer is yes. We can nest them all the way down. In fact, we can also nest select statements for something like this that would produce a single value, because here you're going to want a single value over here, and whether you put it as a something in quotes, or you have some other way to produce what you want there, and that can be a select statement. So anyway, I just thought I'd mention that. So so the point is that you can use them as a table. Well, so anyway, so click through these. What is missing to get all chair names? Select chair from get all the chair names. Well, we would be selecting chair from well, the only place there's a chair is here. So that's got to be department view. Yes. Yeah, all right. So anyway, what are the views? What are the view queries base tables? The view query, it's called the view query, I guess. So it's these two things, because has to have both of them. Okay, so anyway, click through those. Advantages of views, well, you can imagine. You can't, you can insert stuff into a table, but you can't insert stuff into a view because it kind of doesn't make sense. So that's the one thing. Views are only for reading. So there's a lot of advantages to views, of course, saving complex queries and saving optimized queries. In database groups, there's usually one guy in the group or one person in the group that really likes figuring out complex select statements with nested queries and all that, bunch of joins, and so he can sometimes that person will come up with an outstanding perfect select statement that does a whole bunch of stuff, and you can just make that into a view and you can use it from then on. All right, view tables are commonly used in select statements. Using views and inserted is problematic. I don't see how you can do it, but maybe you can try it out. You won't break anything usually. By the way, it is possible to break stuff in your server. Every now and then, about every year or every other semester, somebody will be doing something, and it's usually something like they create a database and then they realize they named it wrong, and so they want to change the name of it, and they do something in some way where all of a sudden the database is inaccessible anymore, and they can't create a new one, or they can't create one with that name, and they've already deleted their old one, and you need to have a particular database name for the autograder to work. Well, have no fear. Just let me know, and I've got a special place in there where I can put for you what table that you have renamed, that one of your tables or databases has been renamed. So anyway, but still, you should always try stuff. If you're in doubt, you can search the web. If you can formulate the question, the Google question perfectly, you can do that. Or you have the ability, you have your own server, you can just try it. So in the next assignment, we're going to have to create views, and we can experiment around there. And I should mention, well, anyway, we'll cross that bridge when we come to it. So anyway, you can go through this. This talks about times when you can use views in statements that update, and so you can read through this and check through it, make sure you understand it. But I don't really recommend it. There's this check option. That I'm not sure. It prevents inserts and updates that do not satisfy a view query and aware clause. So that's interesting. So that's how you enforce a constraint on a table for updates, because it is used, it is referenced in a view, in some view someplace. And similar to, you have this table of employees, and you're gonna get rid of one, and one of them resigns, and before you take the employee out of the database, you got to make sure that there's no references to that employee anyplace else in the database. So it's the same kind of thing. So this is important. So let's try to do one of these. All right. So we're supposed to view. Complete the following statement to generate a view table. Create view country code, because this is the view over here, and that would be the name. And we are asked what to put there. So I'm going to do a copy and a paste. And as this select statement, name as country name, that's good. Something, it must be code, and ISO code 3. So this must be ISO code 3 as code, I think. All right. Okay, what's next? All right. So we have a select statement that's got a join in it, and we want to preserve that, save this magnificent select statement forevermore in a view called country geography, which we want to look just like this. So we've got 3 columns: name, area, and population. Name, area, and population. Well, that's population comes from here, and it's the same name, so I don't have to do anything. I could just put population. And from some table, inner join geography. So it must be country. From country, inner join geography. Okay, that's fine. On TLD equals ID, this ID. Okay, and we don't have to prefix anything with table names, because since we are not referencing any redundant column names, we do not have to use the table name as a prefix to any of these things. It appears. All right, so I'm going to see if this is right. Yes, that's good. See, if somehow we wanted ISO code 2 in our select or in our where, there's no where, then we would need to use the table prefix. All right, makes me nervous. Oh, the check option. All right, so I guess so this is pretty amazing. Excuse me. It's green tea, if you can believe it. It's matcha, actually. All right, so select which statement, select each statement that satisfies the view query. Okay, so the idea is that the select statement selects everything where the independence year is greater than 1811. So it looks like so here we're updating. I guess all right. I'm not sure the answer to this one. It's 9:57. We have plenty of time. So insert into country view, because okay, so this is the base table. And right now, independence year is all greater than. All right, so I'm going to go back and review what option is. Here's a nice participation activity. First of all, databases that allow view updates. A view insert. It may create a row that does not satisfy the view query clause. The view insert or update may create a row that doesn't. A view insert or update. Okay, let's a view insert may, in this case, the inserted or update row does not appear on the view table. From the perspective of the database user, the insert or database update appears to fail, even though the database tables have changed. Okay, so are we using the view name as the target to update? Yes, we are. Okay. All right. Well, you remember before earlier in this session, I said that you can't use a view in a insert or an update. Well, you can, but you have to. You can, and it's possible that when you do that, you do this insert statement, and it ends up making the update. It inserts into country view, which is going to insert into the base table. Oh, I see. It's all just from the same table. Okay. Okay. If it's the same table, I guess you can. Then there should be no problem. All right. So you're inserting into what is this view? Kyrgyzstan, Asia 1991, and we have to see if this satisfies the query. What can happen is, because the query's got this condition here, this condition and this condition, and then you go ahead and use this view as the target of an insert, and then you do an insert on the view, and then you go back and look at the view, and it's like, where's my record? I just inserted it, and it's not showing up when I do a select on the view, and in fact it was inserted, but you're not going to see it in the view because what you inserted in did not meet this condition. See, so what check option does is it makes sure that you don't ever do an insert like this that would not meet this condition, because otherwise you wouldn't be able to confirm that that the insert took place by selecting from the view. All right, I think that's what it means. So I'm gonna it's 10:01. I'm gonna okay, so it's got to be the continent of Africa and independence year greater than 1811 for it to show up when we select this view. Okay, and so I would say This is Asia. And so this would not satisfy because it's got to be, because we would do this and then we would select this and we wouldn't see Kyrgyzstan. Why? Because it's in Asia. And this thing only shows Africa. So that's not a checked. No, not this one. This one is, and the year, independence year, is greater than 1811. So this one would. Oh, wait a second. Wait a second. Updating country view. Updating continent equals Africa. This one. Where name equals Morocco. A name equals Morocco. Set continent equals Africa. And set independence year equal 1944. It's already that. All right. I'm going to say this. I'm going to say it's that. Oh, okay. Continent's not in Africa. Continent is not in Africa. Succeeds since it includes the countries in Africa and independence year greater than 1811. The whole weird thing about this is it already says it's in Africa. It already says it's 1944. You're just so you're if you were looking for there to be an update with MySQL with any database server, when you do an operation like an update, you can look and ask it how many records it affected. And when you're doing an update, you expect it to affect a record. And in this case, it would come back, no records were affected, and you'd say, oh, my update failed. Well, actually, you weren't updating anything. You were just trying to set something to something that was already equal, I think. Anyway, that's that one. Very interesting. Normal forms. My favorite section, my favorite part of databases. Okay, it's reducing redundancy or eliminating redundancy. So redundancy is the reputation of related values in a table. And you want to try to reduce, you want to eliminate redundancy in your databases, across your tables, because if you have redundancy, like somebody's, I don't know, somebody's vehicle name, or so somebody's vehicle in your database, for some reason that particular attribute about you needs to appear on many reports, all around your company, and so so you can imagine that it might appear in multiple places. The problem with having it appear in multiple places is that that's redundant. And let's say you trade in your old vehicle for a new vehicle. It's possible that you end up with inconsistencies in the database as a whole. And so by reducing database into tables that are in their highest normal form that you need, you eliminate the possibility. If your database stores somebody's vehicle, it's only stored in one place, and if it's ever needed, you can create pseudo tables using views for any department that happens to need some information about somebody and their vehicle, for example. All right, so there's some terminology here. We say that column A depends on B. Column A depends on B means each B value is related to at most one A value. So columns A and B may be simple or composite. So here, for example, see, this thing explains it. There's a passenger number 222, whose name is Elvira. Yeah, let's just go to this. Okay, so we have a passenger number. And that's related to a Elvira Yin. And the fact that, let's go next. The fact that first class fares board first. Okay, so this is booking, this is fare class, and this is boarding zone number. And we see that in this table, we would have the keys to this table would be passenger number and flight code. You know, that identifies the unique, each unique record. And passenger name depends on Elvira. Passenger name depends on the passenger number. The passenger number plus the flight code defines the fare class, and the boarding zone number depends only on the fare class. So the fact that first class fares board first is repeated. You see there's redundancy there. Well, there's other redundancy. There's Elvira Yin appears 3 times. Yeah, so anyway, we'll see how this is, we'll see how far down they reduce it in this example. Each number always has the same name, so passenger name depends on passenger number. You see that, so it's each fare class has the same boarding zone, so that's okay. I guess we're done. Okay, well, what we're going to learn how to do is take this table and reduce it down into smaller tables, more of them, that where each fact is only in one place. Like passenger number 22 and Elvira Yin is only in one place, you know, all that. So, and then we use a join to join them back together again to get this exact table, if this is what we in fact want. And yeah, there's some places where, you know, you would want this exact table to look just like this, but you wouldn't want to maintain this exact table. You would want someplace to there be other tables, you know, that are maintained by somebody, and you just use those to get this table. All right, so column names refer to the booking table. Yeah, redundancy is the repetition. Yes, it is. It's the repetition of a value. Oops, what is it? It's a repetition of related values. Oh, related values. Okay, so it's not the fact that there's 3 Elvira Lins here. There's the fact that there's a relation, 22 Elvira Yin. That's the redundancy. Tables that allow redundancy might contain inconsistent data. Yeah, that would be true. Passenger name depends on passenger number means that each name is related to at most one number. Yeah, that's what it means. Each name is related to at most one number. Actually, that's not true, because there can be 2 Elvira Yins, and so that's the same name, but it's related to 2 different numbers. So it's the opposite. Each number is related to a single name. So I got this one wrong too. B implies A means each value of A relates to at most one value of B. Yes. B implies A means A depends on B. Yes, that's what it means. Each value of B relates to at most one value of A. Each value of A relates to at most one value of B. Right. So this in this case, the arrow would be in the opposite direction. Okay. Well, You can finish them. All right, so passenger name is the only column that depends on a non-unique column. Passenger name depends on a non-unique column. Is that true? I don't know. Yes. Boarding zone number depends on fare class, which is not unique. Yes, that's right. This depends on this, and this is not unique. So it should be this. So I've gotten every one of them wrong. Should I see if I can get the next three? No, let's see. You can work on that. All right, normal forms. These are the levels of normal forms. First normal form just means, it's just each cell has only one value. There's no duplicate column names, and there's no duplicate rows. So that's first normal form, I think. What I get mixed up with sometimes is the line, how to define the line between these normal forms. And the good news is it's not so important that you're able to do that. I like to do that because it's intellectually interesting to me. All you have to do, and it'll come natural, is you'll look at a database and you'll have a sense of where the redundancies are, and then you'll create your tables based on that, and you will know how to break down a table that's got redundancies in there. Oh, look, the zip code, the fact that that 96825 is a zip code in Honolulu, is everywhere, is in lots of places. So how do you break that out to make sure that whenever somebody types 96825, for sure the city is going to be Honolulu? So anyway, that just is going to make sense to you. But anyway, some of the going from third normal form and voice cod are kind of that's where you may decide just to keep it in third normal form and so on. But so that's what we're going to learn this today and probably next time. And the next assignment is actually taking tables that are not normalized at all, and you'll learn the procedure, a procedure for normalizing them. Okay. And we set up the foreign key constraints and everything. Tables. Okay, first normal form. First normal form. A table is in first normal form when all non-key columns depend on the primary key. So if a table has no duplicate rows, the composite of all the columns is unique, and therefore all columns or some subset of columns comprise a primary key. Okay, all that means is that if there's no duplicate rows in the table, and you can't figure out what subset of columns would make a good primary key, worst case, it's all the columns together define the primary key. That's worst case. And so, but at least there is a primary key, and this says by definition that can be a primary key, but it's not minimal. And so, we want the most minimal primary candidate key. So all columns together, that's a candidate key. But for a primary key, we want it to be minimal. And so one column is the best. And then if it's going to be one column, if there's more than one column that could be a key, like at the University of Hawaii, it can be your user ID, your email user ID, or it can be your 8-digit, UHID. Either of those is is a good candidate key. They're both minimal. And which is better? Okay, which is better? Well, I'll tell you which is better. Which one has meaning and would more likely be a candidate for having it be changed? And what it is the 8-digit UHID is better because that's like 8 random digits. I mean, there's no meaning to those digits unless you're, unless it's a sequence of digits that you I don't know, find unlucky or something. And when you first get your ID, and there's nothing else connected to it yet, you may that may be a time where you can request a different ID. But it's possible that somebody will request a different username, and I don't know how UH handles it, but I can see that somebody would want to change their username, and so that would cause ramifications. Anyway, that was kind of a tangent here. Okay, so tables with primary key are in first normal form. With a primary key are in first normal form. So that means there's no redundancy, which is the important thing. Every non-key. Okay, so this is in first normal form. Whatever. In a table with no duplicate rows, non-key columns always depend on the primary key. Yeah. Oh gosh, I've got one right for change. In a first normal form table, non-key columns depend only on the primary key. I don't know, is that true? In first normal form, non-key columns may depend. Oh yeah, sure. Third normal form it has to be third normal form before all non-key columns depend on the primary key. All non-key columns depend on the primary key. Okay. Yeah, so that's false because you can have non-key. Okay, so let's say you have this example I did before where 968, or your zip code defines your city, and there is no zip code that is shared between two cities. Okay, and so if there's a database table that's got employees, there's going to be probably an employee number is the primary key. Well, in there, you're probably going to have your address, and you're probably going to have, your cities, your address, city, state, zip. And the thing is so in there, you're going to have something where you have a non-key column depending on another non-key column. You have the city depending on the zip code. The zip code determines the city. And so, and we're talking about just non-key columns. We're not. So the answer is you can have non-key columns depending on other non-key columns. So this is false. In principle, all tables are in first normal form. I think that's true, unless you're talking about being able to have redundant rows, duplicate rows. All right. Second normal form is when all non-key columns depend on the whole primary key. And in other words, a non-key column cannot depend on only part of the composite primary key. So we're talking about if a table qualifies as second normal form. Okay, if it doesn't qualify as second normal form, in other words, if there is a non-key column that depends on only part of the primary key, and if you have a composite primary key and it only depends on part of it, then it's not even in second normal form. It's just in first normal form. Okay, so here, for example, the key is both this column plus this column. It has to be those two columns together. Those two columns together uniquely define a row, but we have this field here that only depends on part of the primary key. So this is not in second normal form. How do you translate it into second normal form? Well, you can't have this be where you have a non-key column depending on only part of the primary key. So you break that out and down. So you break it out into a second table where you have passenger number and passenger name, and you would have the primary key be passenger number because it's possible that two passengers have the same name, and then what's left is you leave the passenger number there because it's part of the primary key, and then you just carry along the remaining columns, and you remove the column that was dependent only on part of the primary key. And so to get back this table, you would join these two tables together on passenger number, and you get back this table. So click through that just to watch the animation, and so refer to this. Okay, so let's say you have a table like this, and we notice that email address depends only on the student number. However, score number would depend on both these two together, and letter grade letter would depend on both these two together. So this with this should be broken out into a second table. I guess. All right, which fact is repeated? Oh, the email address, John, 8034, an email address. Okay, that's repeated. All right. What non-key column must be removed to achieve second normal form? Email address must be removed. Now, this is interesting because, we all know that everybody, especially here, we have these email addresses that are from domains all over the world, all over the place. We know that that's unique. We know that that's unique to a person. We are long past the day where a husband and wife will share an email address. Back when email first started, there was a lot of that. But so this could easily in itself be a candidate primary key. Along with this, if you could replace this with this. But anyway, that's a tangent. A table with a simple primary key must be in what normal form? It must be in second normal form. Why? Because you don't have if it's not a composite key, okay, if the primary key were not at least two columns, in other words, if it's only one column, you would never have the case where you have a non-key field depending on only part of the primary key, because the primary key is only one column and there is no part. It's either all or nothing with one column. So if you have a table that's got a single primary key, it's by definition in second normal form. All right, third normal form is redundancy can occur in a second normal form table when non-key depends on another non-key. Okay, so that's what it is. So to achieve third normal form, you cannot have any non-key fields being dependent on another non-key field. So in my example of an employee database, an employee table that's got both the city and the zip code, the employee city and zip code both in the same table, that's not in third normal form. It's in second normal form because it's got a single primary key, the employee number, but it's not in third normal form because it's got there's this relationship between these two non-key columns. So here we have two non-key columns where the boarding zone number depends on the fare class, and so that's a relationship. And so, but this is in second normal form because we have no cases where a non-key column is depending on part of the key. It's a composite key, so you have to ask the question about the second normal form. Well, it's in the second normal form. Now we want it to be in third normal form, so we have to eliminate this redundancy. And to do that, we break it out into another table. We break this out into another table, and we end up and we remove that non-key column that's dependent on that other non-key column. We remove it from this table because that information is now in the fair table, and we join these two tables on the fair class to get back this original booking table. So click through that. A candidate key. So I'm just going to get through, it looks like I'm just going to get through this today. A candidate key is a simpler composite column that is unique and minimal. Oh, okay, a candidate key's got to be minimal. Okay, so what I said earlier about a candidate key can be all the columns together as a huge composite primary key. That doesn't quite meet the definition because it might not be minimal. In fact, it most certainly probably wouldn't be minimal. Minimal means all columns are necessary for uniqueness. A table can have several candidate keys, and so a database designer decides on one. A non-key column is a column that is not contained in a candidate key. So there can be multiple candidate keys but not contained in a candidate key. So it can be a candidate key that is ultimately not chosen to be the primary key, but the fact is that it is in a candidate key. So that makes it so it's not a non-key column. It's a key column. If any column that can be part that could be part of a candidate key is a non-key column, is a key column. All right, so here it says it explains if you have a table that's got ID, social security number, name, what candidate keys are, and you can look at all combinations. Okay, so a table is in third normal form whenever a non-key column depends on column A depends on column B, then B is unique. Columns A and B may be simple or composite. Although B is unique, B is not necessarily minimal, therefore is not necessarily a candidate key. Anyway, so that's third normal form, and you can see what each department has one chair, but the same person occasionally chairs several departments. Course names can be repeated in different departments, but never in the same department. So you can go through this. It's kind of more dense. I'll tell you what, why don't I save third normal form and Boyce Codd normal form for next time, because I am actually going to go further and talk about fourth and fifth normal form, because your assignments, there's a couple assignments later on where you have to you end up reducing something that's in Boyce Codd, and you want to reduce it to fourth normal form because there is redundancies that there's multi-valued redundancies that can occur, and in this setting where we have the instructor and the courses and the textbooks and the departments, that's a common setting also, where you end up with databases, tables where if they're in Boyce Codd, where if they're in Boyce Codd, there's still redundancy, and you want to eliminate those by reducing those tables into higher normal forms. So we will talk about those next week. And I will, so the class next week is going to be either on Thursday or Friday, because I got a whole bunch of stuff Monday, Tuesday, and Wednesday. And so I will see you then. Is there any, do you have a question?
No, thank you so far. Appreciate it.
Okay. All right. Great. Thank you. See you next week.
Yep.
Thanks for watching.